Everyone, and welcome to Module 0.3, the scientific method. Here's your vocab, pause if you need. Okay, so let's start with the difference between a theory and a hypothesis. A theory is when we have a generalized idea about something and we organize it into a theory. So the idea that better memory springs from more sleep. So from that theory, we can create a hypothesis. The easiest way to create a hypothesis, a testable prediction of that theory, is to write an if-then statement. So, taking our sleep idea, we could say, if sleep improves, then memory will improve. Or, if a person is sleep deprived, then they will remember less. Their memory will decrease. You will be asked on assessments to write and to understand how to write a hypothesis. Okay, when we write a hypothesis, we want to make sure that it has falsifiability. This means that the hypothesis, as much as it can be shown to be correct, the evidence can point towards that is true. Lack of sleep does decrease memory. We also want to be able to show that it could be wrong. If you have a hypothesis, let's say, for example, Sigmund Freud had a hypothesis, had a theory about our unconscious, and that our unconscious drove most of our behaviors. But our conscious, were not aware of what was driving those behaviors. And so we'd make up these other things that weren't actually the true thing. And there was no way to test that. Because if you said that, well, no, that's not what's driving my behavior, Freud would say, well, yeah, your conscious isn't even aware. And there was no way to test if that was truly coming from your unconscious. So it lacks falsifiability. When we are going through the scientific process, we use a peer review process. So you come up with your theory, you come up with your hypothesis, and then once you've gone through your research, you've written your article, you have other qualified researchers review the content. Make sure that it's original. Like if someone's already said this before and you're not giving anything new or whatever, that can be an issue. Or it's inaccurate, or you're using data incorrectly, or your data isn't doing what you're saying it's doing. Then all of those reasons, it could be edited. So it goes through a peer review process. In the scientific process, we also want to define our variables. It is super important that other researchers can look at your research process and understand exactly what your variables were. For example, if you were doing a study on happiness, they would need to know exactly how you measured happiness. And just a little tip that I would write down, if it's something abstract like happiness, I would say for an operational definition that the participants rated their happiness on a scale of, let's say, 1 being the most unhappy to 7 being the most happy. That is a clear, measurable way to operationally define happiness. And again, the whole point of this is so that other researchers can test your hypothesis and replicate it. If you've conducted a study and gotten a certain result, the best way to know that your research is valid is for other people to retest it. And they can't do that if they're using some other measure of happiness. Here's an example. So we have a hypothesis. Students are more likely to smile for their senior picture if they have a friendly photographer. So we're going to talk more about independent and dependent variables, but you can kind of guess right now if you think you already know the difference between the two. So here are independent and dependent variables. So how are we going to operationally define what a friendly photographer is, right? We're going to have like a certain script, and we're going to have that person behave a particular way in this experiment. We are controlling that independent variable. But how are we going to measure smiling? That might sound easy, right? Smile, no smile. But let's take a look at these pictures. who here is smiling? You have to clearly, very specifically indicate what is going to qualify as a smile. If it is showing teeth with mouth in an upward, however you describe it, it has to be so clear that others can replicate it. Here's just some other examples. And again, reinforcing that idea. Here's a different example down below. Okay, so two different types of research methods, and both have their strengths and weaknesses. So a correlational study is trying to find the relationship between two or more variables. So we might want to look at something that we can't do an experiment on. We can't put it in a lab, or either because it's impractical or because it's unethical. For example, we could take women who are vaping during pregnancy. This is not an experiment we can conduct because that is causing potential harm to the mother and the child, the unborn child. So we can't do that as an experiment for ethical reasons. So we could do correlational studies. Do you vape? Are you pregnant? Score how many times a day? And then follow that data to see what are the health implications on that baby. This can help us. This type of study can help us see there's a relationship between two variables, but it cannot tell us which one if the vaping caused, let's say premature birth, right? It can't tell us that the vaping caused the premature birth because there could be other variables. Perhaps women who vape during pregnancy are also more likely to do some other behavior, and that's actually causing, let's say it's drinking alcohol, and that's actually causing the premature birth. So correlational data can help us collect data on and find a correlation where we can't otherwise do an experiment on, but it can't tell us a causal link to things. And here's another example, right? This is just giving you like a silly thing. Like these are so strongly correlated. Ice cream sales go up, shark attacks go up. But we can't say that one causes the other because that's not what a correlational study does. In an experiment, this is the only type of study that can tell you cause and effect. So that's its strength. Obviously, the weakness of it being is not always something that can be done in an experiment because it's a controlled environment where we are manipulating a variable. There are three non-experimental methods beyond and sometimes related to correlational studies. The first is a case study. So for example, Phineas Gage here had a railroad pipe go through his head. He lost a teacup size of brain. This is not something we can do purposefully in an experiment, right? This is also not something that happens to a lot of people. So we can't, for example, survey a bunch of people and ask them, how do you feel? Because he lived, by the way. We'll talk about him more later. So he is a case study. They gathered useful, interesting information where they learned about the brain and how the brain works because he lost a part of his brain. So that can give us information that we can't otherwise get. But it's the weakness with this is it's hard to generalize because it's one person. It's more anecdotal. So it still leads us into some possible theories, but it's hard to generalize. Naturalistic observation, you want to think of like Jane Goodall, although I know not all of her work was in naturalistic observation. A true naturalistic observation is observing either through a recording, so you're not in the room at all, or in a very discreet way, being in the environment, but not interacting in the environment and not altering the environment like you would in an experiment. A survey is a questionnaire or an interview where you collect self-report responses. And this has its own faults as well. Here are the faults that it has. So first, there's framing and wording effects. These are so framing, here's an example. We have this treatment A. It's going to do both of these things. how you word the question can change people's answers. It does change people's answers. So if it's worded 200 people will be saved in that positive way, more people are like, yes, treatment A. If it's worded 400 people will die, it's going to lean the other way, right? So framing, the way that we word the question impacts our answers, impacts our data. So that's important. Second, social desirability bias. So we sometimes answer in the way we think will please the researcher or the person that's interviewing us or asking us the questions. Finally, self-report bias. Maybe the question is asking you about your academic integrity. Have you ever plagiarized? Have you ever cheated? And you don't really want to think of yourself as a cheater, or you don't want to acknowledge that you cheated. Or maybe there's a situation where like this is like, am I a hard worker? And like compared to this room, right, she might feel like her perception of herself, because she's comparing herself to all these other students, is, I guess so. But if she was in this room where the others are really slacking off, she might be like, yeah, I am. So there's another self-report bias, is how we perceive ourselves. When we are doing correlations or experiments, we are going to try to make a generalization. We're trying to come up with we're trying to learn something that we can generalize to a population. So let's say, for example, it was high school seniors. We cannot survey every single high school senior. That's our population. High school seniors. How do they feel about graduation, let's say? So instead of asking every single high school student, we get a random sample. This is a group that fairly represents the population because each person is randomly selected to be in the study. It could be like a number generator, but it's diverse and it's equitable. A lot of the older psychological studies were like white middle-class men, and in future replications showed that that's not always true for different groups. And we'll talk about some of those studies this year. So that's our population, our random sample. If we don't random sample, we could be victim to sampling bias, where we're asking maybe like the 5 people that walked out of the bakery, what did you think about those cupcakes, right? Well, that's a sampling bias. It's not representative of all of the customers. It's the 5 people first thing in the morning when they opened. Or convenience sampling, which I'm just giving you an example of that too, is a group that's like readily available to you. So if I'm trying to survey high school seniors and I only ask like the class that's in front of me, that's not going to give me the correct data for necessarily all other students. So in an experiment, that's where we're gonna do something that's next step here. So if it's a correlational study or an experiment, either way, you're going to random sample. You're going to take my whole population and randomly select to get the random sample. Now, in an experiment, you're gonna go to this next step here. So the next step, random assignment, if you hear that in a study and you're unsure, is this an experimental study, a correlational study, you can't tell. If you hear that they randomly assign to a control group or a treatment group, that's going to tell you it is an experiment. Only experiments randomly assign. And what they're doing is they've taken the population, they've gotten a random sample, they've taken that random sample, and they have randomly put the participants either in a control group or an experimental group. Who is going to receive the friendly photographer, who's going to receive our independent variable? They're going to go into that experimental group. And that must be done at random. If you need to write that out on a test, the easiest way to say that is drawing names from a hat or a number generator. Here's just another thing if you want to pause and review it. So our takeaways. Remember, theories connect our observations and give us a general idea, where a hypothesis is going to test that idea, and it has to have falsifiability. Remember that all variables must be operationally defined. That's a really important vocab for us. All experiments need to be able to be replicated, and that's another reason to operationally define, so we can test our hypothesis. Only experiments manipulate a variable, and therefore only experiments use random assignment to put participants in a control or an experimental group. Correlation does not imply causation. Only experiments can test cause and effect relationships. Remember that wording, social desirability, and self-reporting all are things that can influence and change survey results, and all studies need a large representative random sample so that you can generalize, that's an important word, generalize the findings of your research to the population you're intending to study. So that wraps up Mod 0.3, and I will see you in class.